This date is 2018. Yes, ma'am. Page number? Right. This one, right? So the question is, alpha particle of energy 5 MeV, means mega electron volt or million electron volt, is scattered through 180 degree by a fixed uranium nucleus. The closest distance is in the order of, closest distance of approach is in the order of. So you know the formula for closest distance of approach, right? You know that R naught is equal to, what is the formula? 1 by 4 pi epsilon naught. That we can take for actually alpha particle is the 2 Z e square by kinetic energy. Here, the energy of alpha particles is given as Ke is equal to 5 MeV. That means we can rewrite this as actually the distances are given in terms of centimeters. The units of centimeters you can first find in SI units called meters, then you can convert. So to get the value in SI units, all parameters should be in SI units. So kinetic energy also should be in SI units. SI unit of energy should be joule, not electron volt. So here 5 MeV means mega means 10 to the power 6. 1 electron volt should be equal to 1.6 into 10 to the power minus 19 joule. This is kinetic energy. Okay, whereas 1 by 4 pi epsilon naught value is a constant. Right, 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 units. Right, and 2, remember Z. Uh, yeah, so for which nucleus it is bombarding? So it is scattered through a fixed uranium nucleus. So for uranium nucleus, Z is equal to 92. You have to remember uranium is U92, 235 or 238, something like that you will get. But actually in the question they have to give the atomic number of the element. So it should be uranium nucleus for atomic number Z will be equal to 92. But the closest distance of approach is of the order of what? So here E is a charge of electron, Z is given, this is known, and K is also known. So by substituting all, how can you find? Let us see. This implies R naught is equal to 9 into 10 to the power 9 into 2 into Z is 92 into E is 1.6 into 10 to the power minus 19 square, means 1.6 into 10 to the power minus 19 divided by kinetic energy, that is 5 into 10 power 6 into 1.6 into 10 to the power minus 19. Now we are keeping as it is because you can simplify here. 1.6 into 10 to the power 1 and 1.6 into 10 to the power minus 19 get cancelled, and this 10 power 6 you can cancel out with this, so 10 power 3 remains. Then it becomes approximately, you can write something like it is 9 into 2, you can write 18, right? It is 18 into 92 into 1.6 into 10 power minus 19 plus 3 minus 16 divided by what is this, 5, right? So if you simplify this, if you take approximately some value and if you simplify, and even if you take this as approximately 90 for simplification purpose, and if you simplify this 5, how many times it goes? 5, 18. 5 ones, then 5 8 40, so 18. 18 into 18. 18 square into 1.6, something like that you can write. So what we get? You can do it otherwise directly also you can do it, no problem. What is this? 18, 18 into 90, well, direct exact value only let us see. 92 into 1.6, yes, is equal to this one divided by 5, divided by 5 is equal to, yeah, just a second. Yeah, so it is equal to 592, no sorry, 529 into 10 power minus 16. So here they are asked in the order of in the order means only 10 power, only without numericals. So in such case, what we have to do is we have to write the value in one decimal value. Means if we can write as 5.29, if we can write into 529. If you write in this way, you can write this into 10 power minus 2 into 10 power minus 16 is here already. So it becomes 10 to the power minus 18. 10 power minus 18. So 10 power minus 18 meters. Because we have taken all parameters in SI units, so it is in meters. But options are given in centimeters. So how can you convert this into centimeters? You can write 10 power minus 16 into 10 power minus 2 meters. That we can write it as 10 power minus 16 centimeters. So this value you can say like a proportionality relation of take in the order of means. So you can take this is R naught is the order of 10 power minus 16, minus 16. Let us cross check the numeric calculated values then. Here 6 5. Where is this number of types are not into 2 z e square by kinetic energy is 5 10 power 6. One electron volt is 1.6 into 10 power minus 19. Yes. Cross works, cross works. Same only. Okay. Then yeah. So then what just cross check whether did we forget any conversion relations. 1 by 4 pipes not value is this in SI units. Z 92 E kinetic energy is 5 MeV minus 19 6 only. 1.6 into 4 minus 90. Expensive. 10 power 3 only. 9 into No, no, no. Here we did something wrong here. See, actually, 529 point something, right? The power we have taken actually in the wrong way. Plus 2 should be 529 point something. So 5 point if you want to write it, have to write it as 10 power plus 2. Plus 2. So plus 2 means becomes 10 to the power 14 here. Is wrong. Yeah. Yes, then we will come. So calculation shall be take properly. Conversion. 10 power minus 6, 16 plus 2 is 10 power 14 meters. Now if you want to write in centimeters, 10 power minus 12 will be 10 power minus 2 we have to write. So then we will get 10 power minus 12 centimeters. So this conversion we did wrong. 529 will get 529 point something into 10 power minus 16. So this write as if you want to write in one decimal, write it as 5.29 into 10 power plus 2. Plus 2. That is the answer. Is it clear now? Right. Yes. Right. Next one. English. Only concentrate on this. Only alpha scattering specific charge calculations. Yes, ma'am. Page number 224. Question number 12. So the question is, find the frequency of revolution of the electron in the first stationary orbit of hydrogen atom. Find the frequency of revolution of electron in the first stationary orbit. First stationary orbit of hydrogen atom. So what does it mean? So let us consider hydrogen atom having some nucleus with the charge plus Z is somewhere here. Okay, an electron is revolving in a first or stationary orbit means first orbit. Stationary orbit or a non-radiating orbit, discrete orbit, whatever you can call it as. This is the first orbit. So radius, you can take it as R1. In this orbit, electron is revolving. So you are asked to find frequency of revolution of electron in this reciprocal of time period. Okay. So what is time period? Time taken to complete one revolution is time period. So we have to say time period just is nothing but time. Just if an electron is revolving with a velocity v in the first orbit with some velocity v1 or v, then velocity is equal to distance traveled by time taken just by general definition of velocity. Now here, this time we can call it as time period, and this distance is nothing but to complete one rotation. On completing one rotation, travel will be equal to circumference. So here we can take time from this. Time is equal to distance by velocity. This distance will be taken as circumference. Circumference by velocity of the what? Electron. Okay. So here circumference can be taken as 2 pi r 2 pi r radius of the first orbit by velocity of the electron in the first orbit, right? So here 2 pi, okay, just because it is mentioned that for hydrogen atom we have to take what is r1 and what is v1, then you can substitute. Other way, just you can simply, you have to remember the what is that radius of electron in first orbit of hydrogen. We call it as Bohr radius. You remember the numerical value of that. What is that? 0.6, right? So what about velocity of electron? So velocity of electron, if it is just you can remember one relation. velocity of electron in first orbit will be equal to c by 137. So here c is speed of light. So to simplify the calculations, you can take this relation. C is 3 into 10 power 8 divided by 137. So this gives you what value for this V1? So if you take this as V1 is equal to 3 by 137. Let us take 3 by 137. Actually, just you have to do these calculations without calculators. Okay, 3 divided by 137, 0.022. Let us say 0.022. So it is equal to 0.0218 something or 22 into 10 power 8. So or you can write it in one decimal if you want. You can write 2.2 into 10 power 6. So then you can simply 2 into 3.14 into R1 is 0.53 into 10 power minus 10, 10 power minus 10. Here, if you simplify this is plus 6, right? 2.2 divided by 2 into 3.14, 2 into 2, 2 into 3.14 into 0.53, 0.53. So it gives you 3.32. The denominator 32. So 2.2 by 3.32. So you can write 2.2 divided by 3.32 is equal to 0.66 into 10 power 0.66 into 10 power plus 6. If it goes here, it becomes plus 10 plus 16. You will get 16. What is this? Hertz. But options are given in terms of 6.6. So 6.6 means one power will reduce. So it becomes F will be equal to 6.6 into 10 to the power 15 Hertz. Okay. Right. So which one? 12th one. Try to just and this is done. See, just you first. What is given here is in the next question number 12, page number 226. The question is when a hydrogen atom emits a photon of energy 12.1 electron volt, its orbital angular momentum. What is orbital angular momentum? L. So what is the relation in between this? Have you tried? So here, hydrogen atom emits photon of energy 12.1 electron volt. I'll take NH. The difference of energy levels to consider it will be based on what do you call it, spectral series. Where you have to start into actually spectral series. We have to discuss it. So if you after discussing that, we'll see this. Okay. So because energy, radiation, or spectral series electrons, if you want to know, you should know what is the spectral energy difference between two levels in terms of environments. Yes, ma'am. This we have discussed just now, right? Please mention that if you what you call if an alpha particle of energy from an EV is scattered through one of these by fixed degree nucleus, the first distance is in the order of. So we have to take close distance of approach is this formula. 1 by 4 pi into 2 z e squared by k. Okay. So like 1 by 4 pi is a constant, its value is and 2 z because it is mentioned that it is supposed to square root 2 billion nucleus. So the atomic number is z equal to 92 and E is the charge of electron. It is 10.6 to the power minus 90. You have to should know that. And here kinetic energy is given as 500. Please. Yes, that means it's okay. Clear? Because integration, right? Integration. Cos 2 theta or cos 2. Cos 2 will not be. You shouldn't get like that. The limits are given, right? You shouldn't get like that. In cos 2x you will get, not cos 2. Okay, that means degrees if you know as 60 degree, 30 degree or radians, pi radians, 5 radians, something like that, you fine. But cos 2, sin 2, this kind of values you cannot consider. Then the question is, if this will be here, if the limit is this, shouldn't be. So sign shouldn't be. So the question, yes. No, question, in this question, sign is not supposed to be in this limits. Question is that. Okay.
In this formula, they have given the velocity and they have not indirectly reason, sir. So they have given a field inversely proportional. So how
In this one,
this one, the third one,
the deflection
what this
deflection is
three
not theta.
that
Deflection of vertical is having velocity since ratio of R into the same transverse value, the ratio of deflections.
so then how is it?
Actually, here what we can see, if the transverse magnetic field means magnetic field is this kind of magnetic field, the particle enters in transverse direction with some velocity. Counterverse circular. Okay. Now, if in this, not one particle, two electrons. So one may have some radius, another may have different radius. The velocity ratios are given as this. Then the deflection actually, if it is instead of going in this direction, if it is deflecting, okay, it is deflecting through some vertical distance y. When you can write that distance deflection vertical distance is equal to ut plus of at square with this relation we consider here. You can consider if it is the starting mentioned starting So then what you can take it is y is equal to, if this is 0, the starting point what is called rest of a into t square, where a will be taken as force is equal to mass times acceleration, but here that force is provided by what do you call it? Force equal to mass times acceleration. It is provided by magnetic force is qvb. So A is equal to QEB by M we have to take in place of this.
Yes,
But
sir.
time T, we have to take,
They have given
we should
just
give
the directly proportional so
the
that we
proportion of
can
the
take.
ratio.
So in this relation also we can take the
No, actually, if you ask this distance between, we have to take it as x by v. When the t square is x by v whole square, you have to take. When